Good morning. Today we're working on the Chapter 3 review, starting on page 131. All right, so number one, there are 3 boats on the lake. 6 people ride in each boat. How many people ride in the boats? Draw equal groups to model the problem and explain how to solve it. So what are the important pieces of information? Well, I see that there are 3 boats, and in each boat there are 6 people. So to draw a model, let's represent the 3 boats with circles. And then we're going to put 6 counters or dots to represent 6 people in each of the boats. So now that multiplication problem would be the number of groups times the number of people in each group. 6, 12, 18. All right. Number 2. Nadia has 4 sheets of stickers. There are 8 stickers on each sheet. She wrote this number sentence to represent the total number of stickers. So 4 sheets of stickers. There are 8 stickers on each sheet. What is a related number sentence that also represents the total number of stickers? Okay, so 4 times 8 is 32. Is 8 plus 4 32? No. 4 plus 4 is 8, plus 4 plus 4. So 8, 12, 16. No, that's not 32. 8 times 8, that's going to be twice as much, right? That's going to be 64. So that only gives us one choice. 8 times 4, which shows the commutative property of multiplication. Remember that when we have the same numbers, and if they're an opposite, if you just change the order, they have to have the same product. Okay, number 3. Lindsay went hiking for 2 days in Yellowstone National Park. The first jump on the number line shows how many birds she saw the first day. She saw the same number of birds the next day. All right, so we know that we have 2 days, and we see 2 jumps. So in our multiplication sentence, jumps come first, and then how many is in each jump? Well, I see it goes from 0 to 8, so there's 8 in this one. 1, 2, 3, 4, 5, 6, 7, and 8 in that one. And remember, that makes sense because to have a multiplication problem, you have to have the same amount in each group. You have to have equal numbers. So 2 times 8, so she saw 16 birds. Okay, let's move on to page 132. Okay, Paco drew an array to show the number of desks in his classroom. Write a multiplication sentence for the array. So you recall when we were doing this that we wanted to always write down how many each side of the array represents. So we have 3 rows, and in each row there are 1, 2, 3, 4, 5, 6, 7 squares. So the 3 represents how many rows of desks. The 7 is how many desks are in each row. So write a multiplication sentence. 3 rows of desks, 7 desks in each row, and how much does that equal? So 3 times 7, if we know what that multiplication fact is, we can write that. If not, we can skip count. 7 plus 7 is 14. 15, 16, 17, 18, 19, 20, 21. So 3 times 7, 21. Number 4. Alondra makes 4 necklaces. She uses 5 beads on each necklace. For numbers 5a through 5d, choose yes or no to tell if the number sentence could be used to find the number of beads Alondra uses. So I know she made 4 necklaces, and she has 5 beads on each necklace. So I just wanted to quickly draw a picture. I wanted to find out how many I'm going to have. Okay, so I see that I have 4 groups of 5, 5, 10, 15, 20. All right, so whatever answers I choose, it has to be equal to 20. If it doesn't equal 20, there's no way I can use that. So 4 times 5. Well, yeah, that's what we just showed. Okay. 1, 2, 3, 4 fours is 16. So no, that's not going to work. 4 fives, 5, 10, 15, 20. Yes, that works. 5 plus 4. 5 plus 4 is 9. That doesn't work. Okay. All right, number 6. John sold 3 baskets of apples at the market. Each basket contained 9 apples. How many apples did John sell? Make a bar model to solve the problem. Okay, so 3 baskets, 9 apples in each basket. So in our bar model, we have to have 3 sections, and in each section we will have 9 apples. So the multiplication problem shown by this model is 3 times 9. 9 plus 9 is 18, plus 9 more is 27. So he sold 27 apples. All right, let's move on to page 133, number 7. Select the number sentences that show the commutative property of multiplication. Mark all that apply. All right, so remember multiplication, commutative property of multiplication shows that on either side of the equal sign, we have the same exact factors, but in opposite order. 3 times 2, 2 times 3. So I see 3 on both sides, I see 2 on both sides. Are they in opposite order? Yes. So A is an example of the commutative property of multiplication. 4 times 9, 4 times 9. I see the same factors. I see 4 on both sides, I see 9 on both sides, but they're in exactly the same order. That is not the commutative property. 5 times 0 equals 0. Okay, well, first off, I don't have the same numbers on, same factors on either side. So this can't be. This shows the 0 property of multiplication. 6 times 1 equals 1 times 6. I do see 6 on both sides. I do see the factor 1 on both sides. Are they in opposite order? Yes. So D is a good example of the commutative property of multiplication. 7 times 2 is 14. 7 times 2 equals 14 times 1. These do not have the same factors on either side, so that's not the commutative property. Okay, number 8. A waiter carried 6 baskets with 5 dinner rolls in each basket. How many dinner rolls did he carry? Show your work. All right, so we have 6 baskets, 5 dinner rolls in each basket. We could use an array, we could use a bar model, we could use equal groups, we could use a number line, whichever ones you want to use. So I think I'm going to go ahead and use an array this time. So we have 6 baskets, and in each basket, you know what, I'm sorry. I'm going to use equal groups. I'm going to draw my 6 baskets, and in each basket, I will put 5 dinner rolls. Okay, so I have the 6 circles represent the baskets. The 5 dots in each circle represents the dinner rolls. My multiplication problem will be 6 times 5, 5, 10, 15, 20, 25, 30. 30 dinner rolls. Number 9. Sonia needs 3 equal lengths of wire to make 3 bracelets. The jump on the number line shows the length of one wire in inches. How many inches of wire will Sonia need to make 3 bracelets? All right, so she needs 3 equal lengths. One bracelet equals 6 inches. Okay, so this jump here represents the length of the wire. Okay, so she needs 3 sets of those 6s. 1, 2, 3, 4, 5, 6. That's 2 pieces of wire. 6 more. That's 3. So we have 3 jumps of 6, and we ended at 18. Okay, Josh has 4 dogs. Each dog gets 2 biscuits every day. How many biscuits will Josh need for all of his dogs for Saturday and Sunday? Saturday and Sunday. He has 4 dogs, 2 dogs, biscuits every day. Okay, so I drew a bar model to represent this problem. Each box of the bar model represents the dogs. Each of the 2's in each of the boxes represents the 2 dog biscuits they get. So they will get 8 biscuits per day. But that's now it says Saturday and Sunday. So I could have another bar model to show that. Saturday, Sunday. So how many total biscuits? Again, 8 on Saturday, 8 on Sunday. So 8 plus 8, 16 biscuits. So let's look at what we did here. We multiplied first to find out how many biscuits the dogs got on a specific day, because it says every day. And then we have another bar model with 2 8s in it because they received 8 biscuits each day, and it's at Saturday and Sunday. So 8 plus 8, 16. Okay, let's move on to page 134. All right. Jorge displayed 28 cans of paint on a shelf in his store. Select other ways Jorge could arrange the same number of cans and mark all that apply. All right, so in this array, I see 4 rows, and in each row I have 7. So 4 times 7, what does that equal? What is 4 times 7? 7, 14, plus 7 more is 21, plus 7 more is 28. All right, so we need to choose methods that would give us 28. Is 2 rows of 14 28? So that's the same thing as saying 2 times 14, or 14 plus 14, which is 28. So yes, he could do 2 rows of 14. Could he have 1 row of 28? Sure. Could he have 6 rows of 5? Well, let's see. That would be 6 times 5. 5 plus 5 plus 5 plus 5 plus 5 plus 5. That's 5, 10, 15, 20, 25, 30. No, that wouldn't work. So no, can't do C. 8 rows of 3. That would be 8 times 3, which would be 3 plus 3, 8 times. 3, 6, 9, 12, 15, 18, 21, 24. Nope, can't do 8 rows of 3. 7 rows of 4. Well, I see that my factors are 4 and 7, so that would be the same thing as if you just turned the array, and now we would have 7 rows of 4. So yes, that would work. Right, number 12, choose the number that makes the statement true. The product of any number and blank is 0. Product of any number, so 5 times what is 0? 5 times 10 is not 0. 5 times 10 is 50. 5 times 1, 5 ones is 5. 5 times nothing, 5 groups of nothing is nothing. James made this array to show 3 times 5 equals 15. James says that 5 times 3 equals 15. Is James correct? Draw an array to explain your answer. Okay, so we know that a couple things with this. We know that 5 times 3 is the commutative property for 3 times 5. We also know that if we turned our array, we'd have 5 rows of 3. So yes, he's correct. I didn't change the number of objects in the array. So yes, he's correct. Okay, and in part B, which number property supports this answer? So what I want you to do is look at, write the two problems. He's saying 3 times 5 equals 5 times 3. Which property says that we can have the same factors and it doesn't matter which order we multiply and we'll still get the same product? 3 times 5 is 15. 5 times 3 is 15. That is the commutative property of multiplication. Okay. Let's go on to number 14. Okay, Julio has a collection of coins. He puts the coins in 2 equal groups. There are 6 coins in each group. How many coins does Julio have? Use a number line to show your work. So again, this is just one way of solving the problem. This is not the only way to solve the problem. I could have drawn 2 circles and put 6 in each one. I could have drawn an array of 2 rows of 6. So they're just saying use a number line in this case. So 6 coins in each group. So I know I have to have 2 jumps, so that's 2 equal groups, and 6 coins in each group. Okay, so that's 1 equal group. 1, 2, 3, 4, 5, 6 more will be the second group. So 2 times 6, and we end at 12. 15. Landon collects trading cards. Yesterday, Landon sorted his trading cards into 4 groups. Each group had 7 cards. Draw a bar model to show Landon's cards, and how many cards does he have? All right, so we're going to have 4 equal groups in our bar model. Now it represents the 4 groups, and in each group he put 7 cards. Now how many total cards does Landon have? This bar model represents 4 times 7. 7 plus 7 is 14. Plus 7 is 21. 21 plus 7 is 28. So he has 28 trading cards. Landon buys 3 more packs of trading cards today. Each pack has 8 cards. Write a multiplication sentence to show how many cards Landon buys today. Okay, so he bought 3 packs, and in each pack there are 8 cards. So that represents 3 times 8. And 3 sets of 8 is the same as saying 8 plus 8 plus 8. 8 and 8 is 16. 16 plus 8 more is 24. 16. A unicycle has only one wheel. Write a multiplication sentence to show how many wheels there are on 9 unicycles. 9 unicycles are my groups. Each one has one wheel. So 9 unicycles, one wheel on a unicycle. 9 sets of 1 is 9. Carlos spent 5 minutes on each of 8 math problems. He can use 8 times 5 to find the total amount of time he spent on the problems. For number 17A through 17D, choose yes or no to show which are equal to 8 times 5. So let's quickly do this. So the 8 math problems, I'm going to represent with 8 circles. Each one took him 5 minutes. So the dots represent the 5 minutes per problem. And so our picture shows 8 times 5, as they said in the problem. 8 sets of 5. 5, 10, 15, 20, 25, 30, 35, 40. All right, so we have to have answers that add up. That equal 40. 8 plus 5. 8 plus 5 is not 4. No. 1, 2, 3, 4, 5 fives. 5 fives is 5 times 5. That's not 8 times 5. 1, 2, 3, 4, 5 eights. Isn't that the same as this in different order? Let's see. 8, 16, 24, 32, 40. So yes, that works. 1, 2, 3, 4, 5, 6, 7, 8 fives. Yes, that's good. Okay. Number 18, page 136. Lucy and her mother made tacos. They put 2 tacos on each of 7 plates. Select the number sentences that show all the tacos Lucy and her mother made. Okay, so 2 tacos on each of 7 plates. 7 plates is the all right, so 7 plates, 2 tacos on each plate. 7 times 2, 14. So she has 14 tacos. 1, 2, 3, 4, 5, 6, 7. That's right. 7 sets of 2. 2 plus 7 equals 9. No, she's using 14 tacos, so B can't be right. 7 plus 7. Do we have 2 sevens? Yes, we have 7, 7. So that would work. 8 plus 6. Now 8 plus 6 is 14, but that doesn't represent what she has here. So it can't be D. But E will work because 2 times 7 is just the commutative property of 7 times 2. Number 19. Jason's making 5 sock puppets. He glues 2 buttons on each puppet for its eyes. He glues 1 pom-pom on each puppet for its nose. Write the total number of buttons and pom-poms he uses. Write a multiplication sentence for each. So the number of buttons and the number of pom-poms. So for eyes, he uses 2 buttons per sock puppet, and for noses he uses 1 pom-pom. How many puppets is he making? He's making 5. So 5 puppets, 2 buttons. He needs 10 buttons. 5 puppets, 1 pom-pom per puppet. He's going to use 5 pom-poms. This actually should be the total. So he's going to use 10 buttons for the eyes, 5 pom-poms for the noses. After making 5 puppets, Jason has 4 buttons and 3 pom-poms left. What is the greatest number of puppets he can make with those items if he wants all his puppets to look the same? Draw models and use them to explain. Okay, so let's make 1 puppet. Okay, so in this 1 puppet, he needs 2 buttons and 1 pom-pom. That leaves him 4, take away 2. For the first puppet, he has 2 buttons left, and 3 pom-poms, take away 1. He has 2 pom-poms left. All right, so again, 2 buttons for a puppet and 1 pom-pom. So now after that, he has no buttons left, and he has 1 pom-pom left. So he can only make 2 more puppets. This is my explanation. You can explain however you choose to explain. So the 2 puppets from our drawing, each will use 2 buttons for a total of 4. Well, he only had 4 buttons. So once I use those 4 buttons, I don't have any more buttons left. So no matter how many pom-poms I have, if I don't have any more buttons, that's the most I can make. So the most he can make is 2 puppets. All right, so that's it for our chapter review in our book. You'll do the online practice test today. If you have any questions, review the problems in your math book. If you still need additional help, you can review the video, or you can stop and ask me for assistance if you need it. Tomorrow we'll take our chapter 3 test, and then we'll begin chapter 4. So until then, I know you will do well on your chapter 3 test.